Again, we talked about early Earth, we talked about the layered nature of Earth. Glass is one of the 3 basic types of ceramics, and it's distinguished as having an amorphous or non-crystalline structure. So that also was interesting, and I hope you saw or remember from looking at renewable energy, right? Amorphous versus polymorphous versus crystalline solar cells, right? So you're looking at something that doesn't have any crystal structure when it's cooling that quickly. So they line up in these chains, and there's a bunch of impurities in there, and as the glass cools, the chains don't organize into a pattern. So glass is not a mineral. It has just a really quick cooling period. So the raw materials, this is the predominant material, glass-forming oxides. It's silica, and then there's some impurities, such as boron and phosphorus. The fluxes, they reduce the melting temperatures. So you have a little bit lower temperature than you would otherwise need. Mix in some of these lithium, sodium, lead, some sort of metal oxide gets mixed in. And again, the purpose of that is just to reduce the melting temperature. There are property modifiers which are added to tailor really the chemical durability, the expansion, the viscosity of the glass. Those are more metals. Calcium, aluminum are the predominant metals, oxides. Then there are colorants. If you're going to color the glass, those are very minor additives, less than 1% of the weight. Think back to the Forbes pigment collection. Those are the types of things that you would mix in with the glass to make different colors. And then fining agents are very minor additives, much less than 1%, and they're just there to help prevent bubble removal. If you've ever seen, I don't know, margarita glasses, right, that look pretty rustic, and you see a bunch of bubbles in them, they wouldn't have any fining agents. And a real clear crystal piece of glass would have fining agents to make sure that the bubbles are just gone. So those ingredients are mixed together along with some broken glass called cullet, and they put it into a furnace, glass people, put it into a furnace that's heated to about 1500 degrees. You see number 1, that's where the glass goes in. The molten glass is fed kind of as gobs into an automatic bottle or jar making machine. So this is industrial glass making. In this picture, we're making bottles, right? The bottles or jars pass into an annealing oven. So we'll talk about annealing in a minute. And they are reheated. It softens the glass. It removes any sort of stresses, any micro fractures, and then they're cooled gradually. The whole point to that is to reduce any pre-existing or created in the pouring process fractures or fine lines along which things will break. And then they're inspected. They're at level 5 right there to make sure that their quality standards. Any bottles that don't pass the quality checks of humans looking at them, they're broken and they're returned to the furnace again as cullet. Cullet reduces the amount of energy that you need to melt the glass ingredients, so it makes it a little more sustainable and energy efficient. And then the bottles that pass inspection are packed for dispatch, and then you bring them to Coca-Cola or wherever. Interesting side note: we were at Harvard yesterday, and when we do sound and acoustical tests in the lab, there you've heard that the right sound can shatter a glass, right? We actually buy the rejects during inspection. You see some sort of fractures because in order to shatter glass by human sound or by a speaker, there have to be specific failure planes. That's the only way you can get glass to shatter. So we buy the rejects so that we can show students how resonance can cause a glass to shatter. So other aspects or uses for the rejects. Shaping of glass can take 3 pathways. Discrete, and that's for pieceware, things like bottles, jars, the previous pictures that I showed you, also light bulbs. Continuous processes are used to make flat glass, so sheet glass, plate glass, the glass in the window, etc. And tubing, so for factory, laboratory wear, fluorescent lights are an example of continuous process of tubing. And then fiber making is to make fibers. And fibers would be insulation, right? That's spun glass, and then also for fiber optics. Ancient methods also include glass blowing. We use glass blowing here, right? And this glass blowing is artisan, really. So it's used for making glass objects of high value in small quantities, so things that we use as art, essentially. But most of the glass shaping processes today are highly mechanized. We have computers and machinery that use technology to create these discrete pieces in very high quantities. So spinning, that's similar to a centrifuge. Everyone know what a centrifuge is? Just essentially spin it. It's how you can cast metals as well, and Han will talk about that tomorrow. Pressing, and that's for mass production of flat products like dishes, bakeware, TV tubes. Press and blow, I'll show you the pictures of each one of these. Press and blow is for production of wide mouth containers, things like jars. Blow and blow, that is for smaller mouth containers, and that's things like beverage bottles where you have a small place where you put your mouth, and then also incandescent light bulbs. And then casting is for large items, astronomical lenses. If anyone went to the Museum of Scientific Instruments yesterday in the Science Center, you saw a whole bunch of these astronomical lenses at Harvard. They have to cool very, very, very slowly so that you don't crack the lens. So they get held, as Kay talked about holding, they get held for a really long time, and they get annealed as well to make sure that they don't crack. So I'm going to go up one again. So these are the ways that we shape, and I'm just going to show you a picture of each one of them. This is pressing, and so what happens is you have this hot gob of glass, so it's liquidish, it's dropped into a mold, and then you rotate the mold, and that causes spreading. This is the centrifuge kind of model, causes spreading of the molten glass on the surface. And you can see this is for things like TVs. That's an old TV. You can see the spinning.
There's actually an artist in Michigan that does this exact process using a potter's wheel in his own studio.
And then puts a mold there.
Yeah, he makes a mold and then he casts bowls.
Well, that's lazy, no? As opposed to blowing, right?
Yeah.
That glass, another interesting thing that I heard from Katrina Carmichael, who just graduated with glass, is that it's the only major that is sort of gender biased, and that is that males tend to have more upper body strength as sexes, and so they can, you saw them blowing it with that long metal tube, and then the glass, it's really hot. And when you're turning it, you need a lot of upper body strength. So there's that too. Okay, so pressing, this is for flat pieces, and the glass gobs fed into this mold from the furnace, and then you press it in shape by the plunger. You see the plunger there, and then it's retracted, and the finished product is pulled out, and the force goes in, and you see there's a dish. This is press and blow, and so what's happening here is a hot gob of glass, just like the other ones, drops into the blank, which is the mold right there. Then the mold's sealed shut by the base. A plunger pushes the glass into the mold, and that's made from iron. And then the glass is shaped into a blank, and it's pushed into the neck by the plunger. So you see the plunger coming up from the bottom. And that part of the jar is finished at that stage. But then the mold has two halves, and it's highly polished cast iron. And so the air is blown into the mold, and it expands, and the piece of glass expands, and it fits really tightly against the glass walls. You see number 5 going into 6 is what I'm talking about. Then the mold opens, the bottle's removed, it's annealed. So again, I'll talk about annealing in a minute. And then you have inspection and testing, etc. So that's your wide mouth things, press and blow. Casting. After the cooling happens, after solidifying, so the glass goes from a liquid to a solid, it has to be finished by things like lapping and polishing. So this is not often done except for very special jobs, smaller lenses, things like that. So astronomical lenses, you have casting. This is how you make glass, such as plate glass. If you've ever done glass windows, etc. What happens here, you start, the glass is melted, and it's melted in the furnace, and then it's squeezed through opposing rollers. So Oliver, I think, will talk about paper tomorrow. This is a similar thing to making paper, in that you roll it out on these opposing rollers, and the gap between the rollers determines the thickness of the sheet of glass. and then you grind it and polish it to make sure that it's parallel and smooth, that you can see through it.
That's how ceramic components and electrical components are.
Oh, so like
It's tape cast the way it would be with glass, except they pour slip through those rollers, and then it's not really a roller. You have like a moving belt, and then you have slip that's being poured, and then you have like a metal scraper that makes it consistent. And then once that's dry, you put it into a kiln.
and you can adjust where the metal scraper is. Oh, that's cool. So yeah, this is great, excellent parallels between commercial, because you talked about the artisan aspect of ceramics, or commercial ceramics is very similar. Yeah, keep weighing in on this sort of thing. Flow process. This is a situation where you have molten glass. It flows onto the surface of a molten tin bath. So that yellow stuff under there is tin, but it's liquid. The glass spreads evenly. It's less dense. This is similar to the layers of Earth, really. The glass is less dense, so it spreads across the surface of the tin, and you have this uniform thickness, uniform surface. And the great thing about this is you don't have to grind, you don't have to polish. It just makes it very smooth and very clear. So the flow process there.
What's the yellow color?
That's tin, so it's molten tin. So you have this bath, it's like a swimming pool again of liquid tin, and then the glass comes from the furnace, so it's liquid, and it's being poured out in a sheet. So think of, like, you've ever seen those faucets that are square, like this, and the water comes out in a sheet. So you have glass coming out in a liquid, and it spreads out across the tin bath, and then the tin is right up to the surface, and then it comes out on these rollers, or on a conveyor belt. Danner process. In the Danner process, you have this molten glass, and it flows in along a rotating hollow mandrel. So that's a cylindrical rod right there. And then air is blown through it while the glass is drawn. This is how you make things like fluorescent light bulbs and capillary tubes. If you've ever been the medical industry, or remember when you were in high school and do they still do this?
Test
or maybe
tubes.
not? For when they test your blood. You know those little capillary tubes? No? I'm much older than you. Sometimes they give you a lance and you spear your hand and cause yourself to bleed. You put the capillary tube and the blood comes in, and then you can test things about your blood. So little thin tubes are made this way. So any sort of cylindrical stuff. And then glass fibers. This is, as we said, fiber optics or insulation. And so glass fibers can be divided into really two categories with different production methods. One is fibrous glass, and that's for insulation, acoustical insulation, air filtration. Sometimes we pass polluted air or contaminated air through spun glass filters, and it looks like wool. So Sam will talk about wool tomorrow. And you do that by centrifugal spraying. So you have this spray going into a rotating area, and you end up with just spun, crazy wool-like stuff. If you need long continuous filaments, which is number 2, which is what you see this picture of, then you use drawing. And this is a picture of drawing. You essentially have the liquid coming out, and you pull it out, and the spray causes it to dry, and then it comes through and you collect it. So you can see that's fiber optics as opposed to just random haphazard wool-like stuff. And what happened? I went too far forward. No, that's forming of glass fibers. Yep. Okay. Last part is heat treatment. So this is annealing. And what happens with annealing is you heat it to some elevated temperature, again, similar to Kay talking about a hold time, but it happens at the end. And you hold it at a high temperature so that it is cooled slowly, and it's held at this temperature. What that does is to eliminate any sort of stresses that would be on it. And then you cool it very quickly to room temperature. And the annealing temperature is around 500 degrees, so about a third of the way up the Celsius, so about a third of the way up to making it liquid. Tempering is really neat. It's similar to annealing. Glass in your windshield of your car. You've heard of tempering? Have you seen shattered glass in a car? You see it's like granular, right? If you shattered this glass, what would that look like?
Yeah, just break.
Big sharp shards that if you went through that in your windshield, if you're in a car, that's the end of you, right? Because it's like knives everywhere. glass that is tempered crumbles, and so it makes it safer for you to go through it in the unfortunate and unlikely event, given today's seatbelt, that you go through it. And so what happens is you heat the glass somewhat above the annealing temperature, so it's a little bit higher, so that the glass is plastic, so it behaves almost solid, but not quite. You can bend it a little bit. And then you quench just the surfaces by air jets. I'll show you a picture of this in a minute. When you cool just the surface, the top and bottom of it harden, the middle is still plastic, and then you let the whole thing cool, and when the stuff that's already cool, the cool outside, shrink, the inside is a little, is plastic, so it's still expanded. So when the middle stuff cools, it shrinks the outside stuff even more and really, really, really compresses the outside. The reason that we temper glass, again, is for safety. It's also more resistant to scratching, so if a piece of rock or something hits your windshield, it wouldn't scratch as easily as if you had just regular glass on there. And this is a picture of the tempering of glass. So there's a sheet of glass, it's hot. You spray cool air onto the surfaces. So you have cooler pieces and then hot in the middle. And so the cooler stuff gets compressed. The hot stuff is wider. And then when the hot stuff inside cools, you shrink the outside even more. And that makes for a safer piece of glass. So again, that is the